Hey kiddos, today we're going to do a lot of sketching of graphs. These kinds of questions are going to pop up pretty regularly in the multiple choice section of your AP test. So it may not be that you actually have to do your own sketching, but you're going to have to know how to do it so that you can find the answer from their selection. So here we have, this is a graph of f, this first one, and we are supposed to go graph its derivative. We did this. I don't know if you remember. I'm going to assume you don't, but we did this back in Unit 2, back when you were first learning what a derivative was. So we're going to hit it again. Here's how you should sketch derivative graphs. You should first go find all the zeros for f prime, all the zeros of your derivative. So remembering that this is f, zeros of a derivative would be anywhere that the tangent line is 0, so anywhere that the slope is 0, so anywhere that it levels out. So it looks like I've got very many of them. I've got 1, 2, 3, 4, 5, 6. So everywhere that there's a 0 on my derivative graph is where my original graph has leveled off. Okay, and then you're going to go in between and you're going to go analyze the regions. Analyze in between zeros, and all you have to look at is for increasing and decreasing. So remembering all of your vocab from last week, if f prime is positive, then f is increasing. So the fact that f is increasing right here means that the graph we sketch needs to be positive, needs to be above the x-axis. How far above the x-axis? I don't know. Doesn't much matter as long as I come and hit the 0 that I know I have to hit. This region in here is decreasing, so we need to make sure we go negative and come back and hit our 0. This region is increasing, so we need to make sure we go above the axis, but don't fly off to infinity because we got to come back and hit this 0. And then just over and over and over again, and it's going to feel a little strange, but it is a little strange. These go here, and this last one is here, and then this little tail is here. I picked a really curvy thing just so you could see all the ups and downs. Notice how I did not stress about how far up and down, like where are these relative mins and maxes of f prime? We don't know. We don't have that information. The graphs that you're going to have to choose from, because I almost guarantee that these are going to be multiple choice questions for you. You'll just have to know where the zeros are and then pay attention to where it's positive and negative. So we're not going to stress about how positive and how negative. So that's sketching a derivative. But what if they've given you the derivative and you're supposed to go back and sketch the original? So this is a little different. This is our axis. It doesn't look very axis-like, so I'm going to bold it a little bit. Here's what we're going to do. We have to pay attention to two different things. Oh, we also have to have information. So I'm going to make this up on the spot, so it's probably going to be great. We're going to know that f of 0 equals 0. Like you have to have a starting point. So I'm going to do that first. I'm going to plot a big dot at f of 0 is 0. And then I'm going to go make some number lines. And the first one I'm going to make is about f prime and what it means about f. So remember that you're looking at f prime. Well, it looks like here, I don't even have numbers, so I'm not writing numbers down. But until there, f prime is negative, and then it looks like f prime stays positive until here. So these are all positive. Oh, but then it's still positive. So it hits 0, and I'm going to mark that because that's an important point. That would be a critical point where f prime is 0. But it looks to me like f is going to be decreasing until here, and then increasing everywhere after because I'm analyzing the signs of f prime. So I have to draw something that decreases just for a little bit and then increases everywhere after. Okay, the other thing we have to do is we're going to do another number line, and this one's going to be about f and f double prime. So remember that f double prime tells you about the concavity of f. And if I'm looking at f prime, f double prime, I need to analyze the derivative of what I'm looking at. So if I look at the slopes of this reddish graph, it looks to be increasing until about here. So I'm going to try to line it up as close as I can. So f double prime is positive, and then f double prime is negative until that same point here, because it's f prime is decreasing, and then f prime is increasing after. Okay, so if a positive second derivative means that f is concave up, this would be concave down, and then concave up. And now we have the very difficult task of drawing something that looks like that. So I think I made my grid a little too small, but it's fine. We're going to make it work. The hardest part is figuring out where to start on the left-hand side so that you go through the point that you know you have to go through. That's the only point that I have assigned to us. So if I know I need to decrease for a little bit and then increase everywhere after, I better start pretty low. And I'm even going to move these down so that I have a little bit more space. Because again, the actual values don't matter that much as long as you go through the one dot that you're asked to go through. So we're going to decrease, but we're going to be concave up. Remember, concave up is here, concave down looks like this, concave up looks like this. So I need to be decreasing, but concave up until here. After here, I am increasing everywhere after. It's just concavity that's going to change. So we're going to change to concave up until here. I'm trying to line it up with my number line. Then we're going to stay increasing, but change to concave down. I'm going to try to get through that point that I know I have to get through. We just keep passing right on through there. And then once I hit here, we switch back to concave up, increasing. So something like that. Is it perfect? No. Is it all right? Sure. Let's do another. Same thing. We were given f prime. We're going to go graph the original. So first, we're going to talk about, I made my number line too big because the graph only goes from here to here. First, we're going to talk about f prime and what it means about f. So if this is my axis again, then it looks like we are positive until here and negative everywhere else. So this would be an increasing and then a decreasing function. And then we're going to make one that talks about f double and what it means about f. So if I look at the slopes, it looks to be a decreasing f prime until here, so a negative second derivative, and then it increases until here, and then it decreases after. So we're going to do concave down, up, down. Okay. And let's just go through 0, 0 again. They will give you that. They'll have to give you that information. I didn't. It's early. All right, we got to increase and then decrease. We're going to start concave down. Looks like that. Concave up, concave down. So increasing, but concave down looks like this. And I only go that far because after that, I have to decrease the rest of the way. So I'm decreasing the rest of the way. I've got to change. I don't change concavity yet. So I'm going to stay concave down until here. And then I switch to concave up until the dot that I know I have to go through. I was trying not to change to increasing. Sorry, it's all chiggy-chaggy. There it is. Concave up, but still decreasing. And then concave down, decreasing to finish. I don't know why I'm very pixelated today. There it is, or something close. So I'm going to mark this one as F. Last one. What if they don't draw you a picture, they just give you words? Okay, so we got to sketch the graph of a continuous, so I'm not picking up my pencil. It's got to be even, which I hope you remember means it has y-axis symmetry. No roots means it has no x-intercepts. Oh, good. I actually gave you a point this time. F of 0 is 2. So here's 1, 2. All right, here's a bunch of stuff. F prime is positive. That means we have to increase in that region. F prime is negative, means we decrease. This is strange. I wonder what that means. F prime of 2 is 0. That means it's going to level off. If you have a slope of 0, that's where you level off. This would be a concave down region. F double prime is negative. F double prime is positive, is concave up. And then we got a horizontal asymptote. So I'm just going to go ahead and draw a horizontal asymptote in because that seems easy enough to start with. All right. If you notice, all of the regions that we have are for past 0. So I'm just going to focus on the right-hand side of this graph. So from 0 to 2, I better mark 1, 2. 1, 2, 3. From 0 to 2, we are increasing, but we are concave down. So from 0 to 2, we are increasing, concave down. After 2, we have to change to decreasing, but we're going to stay concave down until 3. So decreasing but concave down. After 3, we switch to concave up. So I got to twist this thing around. Oh, that makes sense. That's how we're going to hit our asymptote and keep going. Otherwise, this thing would have a root. Okay, that's not enough, though, because it has to be even. So we have to have y-axis symmetry. So I just have to flip this thing over the axis. I wonder if I'm able to do that today. Let's find out. Increasing until 2, decreasing, change concavity. There it is. That's pretty. I want to point out one thing that I kind of glossed over. I don't know if you can see it anymore, but there was a cusp right here on our original function, not our original, but our derivative function. There are no such things as points of non-differentiability. There's no such thing. So there's no place. No, that's not what I meant to say. I wonder if I'm going to cut this. I'm probably not. There are no such thing as points of non-anti-differentiability. There are places where you can't take a derivative, but there's no such thing as a place where you can't undo a derivative. And that's what we were doing in this question because we were going from f prime to f. So the fact that there was a cusp doesn't mean anything about graphing the original. If I'd asked you to graph the derivative of what was given, you'd have to be careful there, but that was not the case. All right, let me know if you need anything.